All right, in this example, I've got two forces acting at a point, okay, a given point. Two forces. One of them is a 19 Newton force, the other is a 32 Newton force. The angle between the two forces is 118 degrees. And so what I want to do now is find the magnitude of the equilibriant. An equilibriant is the vector that holds this in an equilibrium. In other words, if you had an actual point like, some object, and you had two forces acting on that object, the object is going to move in a certain direction. Like maybe these are two magnets pulling a metal ball or something. It's going to move in the direction of the sum of the two vectors. Well, to create an equilibrium, you want to zero the forces out. You want to add in another force that pulls that object in the opposite direction that it wants to travel with the same magnitude. Okay? So, what we want to do is find the vector that is the sum of the two here, right? The sum of these two vectors, and then subtract that and go in the opposite direction. So, if I label these two vectors as, let's call them vector V, we'll call that one vector V and this one vector W, then their sum, vector V plus W, is going to be the resultant vector. It's the vector or the force that's in the direction that that object is moving or prone to move. So what we're going to do is create a new force in the opposite direction. So it'd be the negative of V plus W. Right? It's the negative of that. Okay? It's the opposite direction, same magnitude. And then we want to find, so not only the magnitude of that, so I want to find the magnitude of the opposite of V plus W. Well, it's obviously going to be the same as the magnitude of V plus W, right? If you've got, you want two opposite but equal forces to create an equilibrium. So that's actually equal to just the magnitude of V plus W. But then we also want to find the angle that it makes with the 32 Newton force. So in other words, what is this angle here? I'll call that angle theta. Okay? So I want to find magnitude of V plus W and theta. I want those two things. So what I'm going to do is I'm going to first find the magnitude of that side by finding the magnitude of V plus W. Okay? And that's using, that's going to be solving a triangle. I already mentioned in a previous video that adjacent angles in a parallelogram are supplementary. So to find the opposite angle over here, let's see, that's going to be 180 minus 118, right? The 118 is on this side. 180 minus 118 is 62. No, yeah, 62. So that's a 62 degree angle. And so now to find the magnitude of V plus W, I'm going to use the law of cosines, because now I'll draw this over here separate. I essentially have a triangle, which is this lower right triangle, where vector W is one of the sides, vector V is this other side here. It's opposite vector V, so it's the same vector. And then V plus W is this third side. Oops. Magnitude of V plus W. Okay. And now I know that the 62 degree angle is this angle on the bottom right. And so I can use my law of cosines to find V plus W. Okay. So I'm going to start off just plugging stuff in. Remember the law of cosines, if I just sketch it out here, using these three sides, well, actually, I'll just give you one of the formulas. It's, c squared equals a squared plus b squared minus 2ab times the cosine of big C. Remember that big C is the angle that's given, little c is the opposite side. So 62 is my big C, v plus w is the opposite side. That's what I don't know. The other two magnitudes are the a and the b. So when I plug that stuff all in, I get magnitude v plus w squared equals magnitude of v squared plus magnitude of w squared minus 2 magnitude v times magnitude w times the cosine of 62. And then I just plug everything in that I know. So magnitude v plus w. Magnitude of v is known to be 19, so it's 19 squared plus 32 squared minus 2 times 19 times 32 times the cosine of 62 degrees. Oh, and I need to square that magnitude. There we go. Now I plug all that stuff into my calculator. Make sure I'm in degree mode, which I am. And I get 19 squared, where are we at? 19 squared plus 32 squared minus 2 times 19 times 32 times the cosine of 62. And that gives me 814 roughly. So that's approximately 814.1225797. Decimals keep going. And then I want the square root of that, right? So square root of that answer is 28. So magnitude v plus w is approximately 28.5328. Now, I've got everything rounded here originally to the nearest whole number. So I'll do the same thing here. We'll call that 28, right? 28 newtons. Oh no, I'm sorry, rounded 0.5 rounds up, 29 newtons. I think it's best to try and round everything to the same place value as the given information, just so we don't have a discrepancy in accuracy here. Okay, and then I still have to find this angle theta, all right? What's interesting is that I know that angle theta and this other angle down here, right, the angle on the bottom left of that triangle, are going to be supplementary. And so if I could find this angle down here, I'll just shade it in. That angle down there on the bottom left of the triangle, then I just subtract that from 180, and that would give me angle theta, because this forms a straight line here, right? Straight line or 180 degree angle. So, if I could do that, I guess the question is, how do I do that? Well, I now know a side and its opposite angle. I could use the law of sines to find, because I know this side, to find the opposite angle, right? So the law of sines tells me that the magnitude of v plus w over the sine of 62 is equal to the magnitude of v over the sine of whatever this shaded angle is. Maybe I'll call that angle alpha. I know I'm running out of letters here. We'll call that angle alpha. Okay, so we'll call that sine of alpha. So then I just calculate this and solve for alpha, plug in what I need, or plug in what I have. Now the magnitude of v plus w, I've rounded this pretty significantly, and I don't really want to use the rounded value there. I'm going to try to keep some accuracy here. So I'm going to just go ahead and plug in, oh, how am I going to do that? Well, I already have it, I have this still on my calculator, so I'm just going to go ahead and keep all those decimals there. So it's approximately 28.5328 over the sine of 62 degrees equals magnitude of v, which is 19, over the sine of alpha. Okay, and so I want to solve for alpha. I'm going to cross multiply and divide out. So it's going to be this 28.5328 times the sine of alpha is equal to 19 times the sine of 62, and then divide out by that 28. And so alpha, if I want to keep all my decimals as long as possible here, this is going to be a little bit interesting. What I'm going to type in is that alpha is the inverse sine of a big quantity. It's going to be 19 sine 62 degrees over, now I have this 28.5328. When I put this in the calculator, I'm going to use the answer. I'm going to, because I still have that stored in my previous answer, I'm going to use the ANS on my calculator. Okay, so this is how I would type it in. So I'm going to say inverse sine of 19 sine 62 divided by second answer. And there it is. 36. Almost exactly 36. Okay. So that's a 36-degree angle. But that angle, remember, is the shaded angle here, alpha. Right? So that's a 36-degree angle. So how do I find theta? Theta is what I'm really looking for. Well, I subtract the 36 off of 180. So now I do 180 minus the 36. That should give me 144 if I'm not mistaken. Yep, 144. So that's my angle theta. So there's two answers to this question. One is the magnitude, and we're rounding that off to 29 newtons. The other one is our angle theta, which is 144 degrees, again, rounded to the nearest degree, okay? So, kind of gives you an idea of how you would find an equilibrium. Again, the equilibrium is the opposite of the sum of the other forces. Now, you can do the same process if you had more than one force, okay? You could, if you had more than two forces. If you had 4 forces or 5 forces, you could add them all together again. It may be best to add them 2 at a time. You know, if you had forces V, W, X, and Y, you know, you could take V and W, add them together, then add that to X and add that to Y. Add them 2 at a time to get the resulting force, then subtract and get the negative of that to get the equilibrium. Okay, so again, you're just adding them. It doesn't matter what order you add them, you just add them all together, and then that would be your magnitude there, and then you could find the angle from there using a little bit of geometry, okay? Or trigonometry, I guess, combination of the two. All right, so it's quite a process, right? We had to use both the law of cosines, the law of sines. We're trying to solve triangles here. There is some information in this triangle we don't know. We don't know the third angle up here, which we could find simply, but it's not really necessary for the problem. So in these problems, we may not solve the entire triangle, but we're going to use the concepts involving the law of cosines, the law of sines, and the angle sum formula to solve, or at least find some of the missing pieces of the triangles.